Okay, let's dive right into this. Today we're unpacking a really fascinating intellectual boxing match from 1983, one that fundamentally changed how economists view global market stability. We are exploring a brilliant paper by A.D. Woodland called Stability, Capital Mobility, and Trade. In this explainer, we're going to see how a simple mathematical assumption created a massive economic paradox, and then how Woodland completely dismantled it. Woodland wastes absolutely no time calling out a previous theory right out of the gate. He directly challenges a 1979 paper by two economists, Das and Lee. Basically, Woodland argues that a super complex economic paradox they introduced was actually just the result of using the wrong mathematical engine. It wasn't some weird quirk of the real world. It was literally just a glitch in their theoretical model.
So here's our roadmap for this explainer. First, the stability paradox. Second, competing market mechanisms. Third, the Walrasian solution. Fourth, revisiting the mixed model. Fifth, tariffs and trade taxes. And finally, the big takeaway.
Starting us off with Section 1, the stability paradox, or the Dassley mystery. Let's start with the exact problem that agitated A.D. Woodland in the first place. You see, Das and Lee were trying to figure out what makes international trade and investment stable over time. But to actually make their mathematical model work, they argued that this bizarre, hyper-specific condition had to be met. And if it wasn't, well, their model suggested the global economy would just spiral into instability. This severely limited our understanding of global economics because, frankly, it just didn't make intuitive sense. The crucial point of their whole argument relies on this idea of a factor intensity reversal. Das and Lee believe stability was only possible if this phenomenon existed. So what does that mean in plain English? It means that building a car, for example, would have to be highly capital intensive in your home country, requiring lots of heavy machinery and investment, but somehow that exact same car would need to be non-capital intensive, maybe heavily reliant on just manual labor, in a foreign country. For the global market to be stable, their model required these extreme opposites to exist simultaneously for the exact same good.
Well, Woodland looked at this highly restrictive requirement and just wasn't buying it. Publishing a brilliant rebuttal in the International Economic Review, he set out to prove mathematically that this whole factor intensity reversal thing was totally unnecessary for market stability. The problem wasn't the global market. The problem was how Das and Lee were measuring it.
Which brings us to Section 2, competing market mechanisms, and the great debate. To really appreciate Woodland's fix, we need to compare two competing engines of market adjustment. Das and Lee used what's called a mixed Walrasian-Marshallian mechanism. Think of this as an asymmetrical engine, where different parts of the economy operate under completely different laws of physics. Woodland, on the other hand, championed a pure Walrasian mechanism. This is a symmetrical engine, where every single part of the system plays by the exact same rules.
Let's look a little closer at Das and Lee's mixed model. They treated goods and capital with completely different behavioral rules, creating this really lopsided theoretical world. For goods, like our car example, they assumed prices would automatically adjust if there was too much supply. Makes sense, right? But for capital, they didn't look at price. They said international flows of capital adjust based on differences in rental rates between countries. Honestly, it's a bit like trying to referee a sports match where half the players are playing basketball and the other half are playing soccer. It's chaotic.
Woodland's framework comes in and completely flips this dynamic. By utilizing a pure Walrasian approach, he leveled the playing field. He just assumed the exact same behavioral rules for all market participants. By treating trade in physical goods and trade in capital symmetrically, meaning everything responds to excess supply and demand in a unified way, Woodland essentially fixed the glitch in the matrix.
Let's look at Section 3, the Walrasian solution, and how symmetry actually solves the paradox. Now that we have this symmetric engine in place, let's look at the actual fix. With his new model, Woodland derived his own conditions for stability, outlined in his Theorem 1. And notice what is entirely missing here? The factor intensity reversal. Instead of demanding extreme opposites in capital intensity between nations, Woodland's math translated to a much more elegant truth. First, cross-price derivatives of excess supplies just need to be opposite in sign, so they don't dominate direct price effects. But the real kicker? Stability simply depends on the average world capital intensity of a good. Not opposing extremes, just a simple global average. As part of that theorem, Woodland also sharpened Dawson Lee's work regarding consumer preferences by bringing in something called the Gorman polar form. Now, Dawson Lee thought nations needed perfectly identical preferences for the whole model to remain stable. Woodland proved that's way too strict. Nations can absolutely have different cultural tastes and demand preferences. However, to maintain mathematical stability, their income responses, meaning how their spending changes when their overall income changes, must be identical, assuming prices are the same. It's just a much more realistic view of global consumers.
So why does this symmetrical model work so beautifully? It's because the Walrasian mechanism ensures that the rental rate on capital is exactly the same in both nations. Capital isn't chaotically chasing different localized rental rates. There is a steady, common global baseline. Because of this, when the price of capital increases, the output of a capital-intensive good will predictably fall everywhere. The net supply effects are perfectly determinate. No crazy paradoxical reversals required whatsoever.
Moving on to Section 4, Revisiting the Mixed Model. Why did the reversal happen in the first place?
Woodland was a pretty thorough investigator. He didn't just propose a shiny new model and walk away. He dug in, which begs the question, why on earth did Das and Lee's mathematical engine spit out such a weird, highly restrictive requirement in the first place? Let's trace the actual mechanics of their error.
In their asymmetrical model, the chain reaction looks kind of like this. Step 1, capital moves from the home nation to the foreign nation. But because their rules were mixed, Step 2 sees capital rental weights rise at home but fall abroad. They're moving in complete opposite directions, which leads to Step 3, where the supply of a capital-intensive good increases abroad but decreases at home. This created massive mathematical ambiguity in the net world supply. Dawson Lee couldn't solve this ambiguity naturally, so they sort of brute-forced a resolution by inventing that strict requirement of a factor intensity reversal.
But here is Woodland's ultimate mic drop. He mathematically proved that even if you force yourself to use Das and Lee's flawed mixed model, their strict requirement for a reversal was still overkill. If you actually run their math correctly, the relative capital intensities between the two countries simply needed to be the same sign, not polar opposites. So Das and Lee weren't just wrong about which model to use, they were actually too strict within their own flawed framework.
Now for Section 5, Tariffs and Trade Taxes. Let's look at real-world application. Okay, let's take these dense, abstract theories out of the academic clouds for a second and see how they apply to something highly practical that impacts all of us. Does a tariff actually reduce the world price of a taxed good, like politicians always hope it will? Woodland mapped out this clear chain reaction to prove it absolutely does, assuming we use the right model. At time 1, an import duty is applied. At time 2, we ensure our Walrasian stability conditions are met. At time 3, we verify that the imported good matches the world average capital intensity. If those rational conditions hold up, then at time 4, the world price of the taxed good successfully and predictably falls.
And looking at the underlying calculus from Woodland's paper proving this, well, the takeaway is incredibly clear. I promise we're not going to solve these equations right now. But this rigorous math confirms once and for all that factor intensity reversals play zero role in determining if a tariff will actually work. Predictable trade policy relies on global averages and symmetrical market behavior, not localized weird paradoxes.
Which leads us nicely into Section 6, the final takeaway, and the power of symmetry.
As we wrap up this intellectual journey through 1980s macroeconomics, let's really crystallize what Woodland achieved. By simply assuming that all markets, whether goods or capital, and all participants play by the exact same symmetrical rules, Woodland dismantled a deeply confusing paradox. He gave us a much cleaner, more realistic lens for viewing international trade. Stability doesn't require extreme opposite behaviors in different countries. It seamlessly relies on the average world capital intensity.
I want to leave you with this provocative thought to chew on the next time you hear policymakers debating global tariffs and capital flows. If symmetrical assumptions fix theoretical paradoxes, how many of our real-world global policies are currently failing simply because they're built on chaotic, asymmetrical models? It's a powerful reminder that sometimes the most complex economic problems are solved just by ensuring everyone is playing by the same rules. Thanks for joining me for this explainer, and keep questioning the models.